Now, weather is something that changes very rapidly, quickly. As I said, that it might be very sunny with bright sunshine, but after a few years, it might rain very heavily. So now this is the process through which the evolution of the atmosphere took place. In the Delhi NCR region, you realize that the particulate matters that are present in the atmosphere are so harmful for you. That is why, please remember, their increase in the number or composition within the atmosphere is a very, very harmful phenomena also. Majority of the clouds are present in your the layers of your troposphere, but there are certain clouds like... Hello aspirants, welcome to PW OnlyIAS. I am here Harpreet Singh with another lecture from the Physical Geography series. Today, please remember, it is very important. We are starting with the climatology or the climate section of the Physical Geography. And out of that section, the first chapter, the very basic chapter, is the composition and the structure of atmosphere. Remember, with the coming lectures, you will be seeing a lot of topics related to, let us say, temperate cyclones, and the various concepts that you often find it very difficult to understand. In the coming lectures, which we are going to deal with climate, weather, and the related issues, every single topic will be very clear to you. So make the best use of the lecture. As I've already told you, have your A4 sheets along with you. Make all the diagrams and the maps, whichever I'm making in the class, so that you are able to understand each and every concept and able to revise it for the examination, be it prelims or the mains examination. So today's lecture, as you can see over here, is basically composition and structure of the atmosphere. Now, let us begin with this lecture. But before we begin, please remember, this is a QR code for the Telegram account. Now, this Telegram account will direct you to a resources full of geography material, anthropology optional material, and along with it, society and social justice material. So this is the Telegram account of mine with PW OnlyIAS. So please subscribe to this for all the latest updates and information. Okay. Now, before I talk about the atmosphere, in the first lecture, we had already talked a little bit about the atmosphere, how it was evolved. We'll be dealing with that in this chapter also. But before we begin with the topic of atmosphere, let us firstly understand what is weather and climate. Now, let us assume you are enjoying yourself in your room and it is bright sunshine. And after 15-20 minutes, you see there is heavy rainfall. Do you realize there has been a sudden change in the conditions which you are experiencing right now? It was bright sunshine and after that rainfall. Now, similarly, after a few hours, you again see bright sunshine. So what do you call that? Is it weather? Is it climate? Something very confusing also for many. Please remember, when we talk about weather, these are short-term state of the atmosphere at a particular place and time. So at any particular place, what are the conditions of the atmosphere? Let us say that it's raining, whether it is very bright sunshine is there, or it is cloudy. So those conditions, which are very short term, these are known as weather. Now, it includes like humidity, whether the humidity is high or low, whether it is raining or not raining, whether it is bright sunshine or not, or for that matter, winds are blowing or not. So these are very short term duration things. But overall, when you realize that, when we say that there is monsoon type of climate, now, monsoon type of climate is a very broad word. When we talk about monsoon climate, we talk about reversal of winds, which we'll be studying later on in the series, where you see during the summertime, you see the monsoons coming and the winds are basically flowing from the Indian Ocean side. And on the other hand, during the winter time, there is reversal. So overall, we call it or Indian region or Indian subcontinent region as a monsoon type. It is a broad categorization, long duration processes are involved. So that is why climate is a long-term average pattern of weather conditions over a large region. Weather usually studied for 30 years or more. That is why, do you realize when we talk about the concept climate change, why climate? Because overall, when we talk about a region, there is a certain set of broad generalization, what type of climate would be experienced in that region during winters, summers, or whatever be the case. If there are certain changes in that, that is why we use the word climate change. So climate is basically referring to a word which is a long-term study of weather itself over a larger region, over let us say more than 30 years also. And based on that, we derive that this is the weather. Now, this is the climate. Sorry, this is the climate. But on the other hand, if you see weather is basically talking about short-term, day-to-day changes taking place in a region. That is what is weather. So weather and climate. Now, if I want to differentiate between both of them, first you can quickly copy it if you want. Okay. Now, Pause the video, copy it. Now, let us see weather and climate. What are the differences? See, what we've already studied the definition. Having studied the definition, you should be aware of what are the differences. Now, let us say this is weather, this is climate. Now, I told you duration, it is short term, day-to-day changes that are taking place. This is long term, on an average 30 plus year is taken. That in 30 years, what are the general weather conditions present day-to-day basis in a particular region, and based on that, you decipher the climate of a particular region. Area, it is generally confined to small areas when we talk about, because weather are local level conditions for a shorter duration. So that is why small region, this is larger region. Now, weather is something that changes very rapidly, quickly. As I said, that it might be very sunny with bright sunshine, but after a few years, it might rain very heavily. So, changes very rapidly. But this is again, changes slowly. We don't say that it does not change. Why? That is why the concept of climate change comes. Because overall, if you realize, let us assume there is a region which has an average temperature of, let us say, 30 degrees Celsius. But due to climate change, you realize after 50, 60 years, the average temperature has gone to 35 degrees Celsius. So it is changing slowly, but changing. So that is why changes slowly. Now, if I talk about which is the branch which studies these things. So when we talk about weather, that is dealing with day-to-day activities or changes in the atmospheric conditions, we're talking about meteorology. Right? That is why we talk about meteorological department, because it has to take care of every little condition changes that is taking place in India and around them. Overall, when we talk about climate, the subject that deals with it is climatology, right? Climatology. Now, you can quickly note down whatever is written on the board. Take a screenshot also, right? Okay. We have studied what weather is, what climate is. So these two concepts are absolutely clear in your heads, hopefully. Now, following this pattern, let us come to the topic that we have to study, that is atmosphere. Now, atmosphere is one topic that you have been studying since you were in school days, something very interesting, something that talks about the various gases, the matters, particulate matters, and for that matter, what all gases that are surrounding this earth. And it is always very interesting to study also. That is why, because it talks about various layers. How come these layers are formed? How come these density of the layers keep on changing? Why there are certain, let us say, shooting stars seen in certain layers? Where is the International Space Station located? These are certain types of things that generally create curiosity. Along with it, these are the questions that have been asked also in the examinations repeatedly, in the prelims examination as well as the mains examination. So let us have a look at them. Atmosphere. So whenever I talk about atmosphere, you know that atmosphere is a mixture of gases, water vapor, and dust particles surrounding the earth, right? It is a mixture. Now, gases are present, water vapor are present, then you see the dust particles are present. This is the basic understanding which you read in your NCERTs also. Why I have very specifically mentioned here? Because this is the definition in NCERT. And this is the simplest definition also that you can come across. Now, the question arises, sir, if these gases are there surrounding the Earth's surface, how they are there basically? It is because of the gravitational force of the Earth. So, it is held by the Earth's gravitational force and rotates along with the Earth, because it is an integral part of the Earth's mass itself. The air is an integral part of the Earth's mass. So, that is why it is an air is integral part of the Earth's mass. This statement is very, very important. Why? Why? Because this has been asked in the preliminary examination as one of the statements, right? As a statement. So you should be very well aware of this statement also. Now, 99% of the total mass of the atmosphere is confined to the height of 32 kilometers from the Earth's surface. Now, let us say you are right now on the Earth's surface. If you go 32 kilometers, 99% of the mass. Why? Because as you go higher and higher, the density keeps on decreasing. So even though you might reach great heights, density will be so less. So what will happen? That is why we say the mass, the lower layers are denser in nature. So that is why they contribute more to the mass. So that is why the mass or the total mass of this atmosphere, 99% is confined to the 32 kilometers from the surface of the Earth. This should be very clear in your minds. Absolutely clear, right? Okay. Now comes, having studied what atmosphere is, brief idea, brief details. Now let's see evolution of atmosphere. Remember this, we have studied this in chapter 1 also. where we had talked little bit details about the creation of lithosphere, hydrosphere, and atmosphere. We are again repeating it because it is relevant here. Initially, when the Earth was formed, it is generally assumed that it had hydrogen and helium, that is known as primordial atmosphere, before the modification took place. So initially, hydrogen and helium were the main components of the Earth's atmosphere. Later on, we see that solar winds, because of the solar winds, this basically, there was a loss of the original atmosphere that was composed of hydrogen and helium. So these are the representation of what? These are solar winds. Let's mark it also. This is what? Solar winds. So the loss of primordial. Primordial means original, old. So originally it was hydrogen and helium, and later on, because of the solar winds, this hydrogen and helium basically got lost because of the solar winds. Now, next stage that happens is degassing. Now, initially we realized that, let us assume that the Earth was a hot bowl. Slowly it started cooling. Now, what happened is, when it started cooling, a lot of gases were released from the interior, which were like water vapor, other gases being nitrogen, carbon dioxide, methane, ammonia, and little bit of free oxygen. Now, when these gases were released, it replaced now, because these other initial primordial atmosphere, which was of hydrogen and helium, was basically gone away with the winds. So now these things came up, and these added to the atmosphere initially. Now these composed of again water vapors, nitrogen, methane, then you have carbon dioxide, ammonia, and free oxygen. Now please understand, this will later be modified. Now this is a process in which a lot of components were added to the atmosphere. Now this is an evolving process, right? Now this process of cooling of the Earth and the release of the gases from the interior is basically referred to as a term degassing. So you should always remember this. Now, last stage, that is a stage 4. Many people have in the previous lectures had questions, sir, in the NCERT only 3 stages are mentioned. Why have you mentioned 4 stages? Please remember, NCERT mentions this also as an initial condition, which though not necessarily mentioned as a stage, is taken as a stage in this lecture. So this is also a stage. That is why I have taken 4 stages. Otherwise, it is absolutely correct. There is nothing wrong in that. So it is basically in alignment with what is mentioned in the NCERT also. Clear? Okay. Now, 4th stage is, please understand, modified by photosynthesis. Now you realize that as Earth started cooling, there were water vapors were released. Obviously, you will realize that cloud formation will take place. So because of that, rainwater fall started, again rain started, and it got collected into the depressions forming oceans. Now you know that very well. When you see Earth from a distant view, you basically see it in this shape, right? Geoid shape, which is like complete curves are here. But on the other hand, if you remove the oceans, you will possibly imagine that Earth is something like this. It is basically the presence of the water on the surface of the Earth that basically gives it a proper shape. So this is what? Water. Now what happens is, as rainwater is following, there were depressions there which got filled. And as they got filled, they were known as oceans or even seas. That is why this is saying that rainwater falling got collected in the depressions forming oceans. Oceans formed within 500 million years from the formation of the Earth. Now, when the Earth formed, after 500 million years, you realize that this process took place and the process of formation of the oceans took place. Now, 3,800 million years ago, life began to evolve. And now these are because of the complex reactions or amino acidic reaction that took place, that life basically evolved according to the scientist. Now, initially life was confined to the oceans. Now, initially, whatever life forms were there, they were confined to the oceans initially, right? Now, what happened is, ocean began to have contribution of oxygen through the photosynthesis. Now those plant-based life, whichever it was, it started again the formation of photosynthesis, and then oxygen became a component of the ocean. So ocean became oxygen rich also, and slowly then oxygen started releasing also. Now eventually 200 million years ago, oxygen began to flood the atmosphere. Now because of that oxygen being released, that basically became a part of the atmosphere also. Now what is going on is, this basically led to the modification of the atmosphere, where oxygen also became a very, very important ingredient which also started supporting life. Clear? So now this is the process through which the evolution of the atmosphere took place. Now, the topic which basically talks about is the composition and structure of atmosphere. This is the evolution. Now let us go to the concept of composition of the atmosphere. Composition, what it comprises, what are the ingredients at present. So when we talk about it, it is not simply the gases. There are a lot of other components of particulate matter, dust particles are also present. So we'll be considering those aspects also, again in alignment with the NCERT, and certain other facts may be added. The atmosphere is composed of gases, water vapor and dust particles. This is a direct line that I picked up from the NCERT. Why? Because few years ago, there was a simple question that was asked that it is composed of gases, dust particles, water vapor. So all the three were right. So this statement, that is why, becomes important. Now, the important thing is, it is not so simple also. If I take little bit more standard form, let us say more what is present in other books also, what UPSC is now taking you to is, there are certain permanent gases, there are certain variable gases, and there is particulate matter. Again, dust particles, aerosols, different kind of matters that is present. So these are the general compositions which we see. Now this is simply a statement that is written completely correct, not wrong. But this is, when we go in more detail, we'll be realizing all these things. Now we have to study all these things so that we get to know better about the composition of the atmosphere. Now, when I talk about the permanent gases, this is somewhat approximate percentage in which the gases are present in the atmosphere. We'll be telling to which layer also as we move ahead in the class, because there is a concept of homosphere and heterosphere also. Right now, simply understand that this is a roughly a percentage which is almost similar, but obviously due to pollution, due to the anthropogenic activities, the percentage of, let us say, carbon dioxide might increase, which is leading to a lot of problems. But overall, this is the percentage. Now, if you will see here, nitrogen 78.05%, close to 78%, oxygen close to 21%, argon 0.93%, carbon dioxide 0.036%, neon 0.002%, krypton 0.001%, helium 0.00008%, xenon 0.00009%, hydrogen 0.0005%. Now, the problem that arises is, how can we remember this, right? See, certain people create their own mnemonics to understand it. Some people try to remember the facts and figures also, but then remember what happens is, by the end of the syllabus, when you have studied a lot of subjects, it is quite possible that you might forget the percentages also. Initially, when you are studying a subject, at that particular moment, you might remember it. After 1 month or 2 months, when I ask you, possibly what is the percentage, you can tell me about nitrogen, oxygen, possibly argon. After that, you will not remember the order also. So leave along the percentages. This question is very important. Why? Almost every year in the various PCS examination, the order is asked. Now the question that arises is, it is not necessary that they might ask you the initial order. They might take up argon, neon, xenon. In that particular case, you will be in a state which you will not be able to remember. So knowing this order is important. Now, I created a mnemonic while I was studying, and which was basically helpful for me also. See here. Naughty old aunt. Now, whether you want to put naughty old aunt or auntie, it is up to you. Naughty old aunt cooks nice kheer, hot, extra hot. So you can imagine there is a old aunt who is cooking kheer, which is hot. No, it is extra hot. So how do you remember? Naughty old aunt cooks nice kheer, hot, extra hot. Now over here, nitrogen, oxygen, argon, carbon dioxide, neon, krypton, helium, xenon, and hydrogen. So remember, hydrogen is lesser than helium. Clear? So this is something that you should always remember and you should understand. This is a mnemonic. Possibly you will be able to remember the order well. Just read it twice and thrice and you will remember the order. Clear? The only thing where you can make mistake is possibly because H and H are mentioned. So please remember, helium is more than hydrogen as a percentage component. So that is why this is, if you remember this, you will be able to solve, provided you remember the mnemonic. Clear? Now, this is a permanent gases. Now, when we talk about the variable gases, see, again, different books try to categorize different things. So we are broadly generalizing. We have put over here water vapor, we have put here methane, and we have put here ozone. Clear? Now see, under them, if you realize water vapor again is a very important ingredient. Many people get confused. That's a vapor is present. Please remember, we are not talking about boiling of water. Boiling of water is taking at 100 degrees Celsius, yes. But water vapor formation is taking place under normal temperature also. Remember that. That is what is contributing to the water vapor in the atmosphere. There's a difference between evaporation and the difference between boiling. So boiling takes place at 100 degrees Celsius, but evaporation, which is adding water to the atmosphere, is taking place under normal temperatures also. That is why if you realize this is an invisible component of the atmosphere, but very important and intricate when you talk about concept of climate change and greenhouse effects and all, it's very important ingredient here. It is also known as vapor in the gaseous state, and it is an invisible component. It is an invisible component of the atmosphere. Clear? That is why its concentration in the air varies depending upon the location. Now, if you realize, in the warm and the tropic region, if you realize, it is 4% by volume. Now, why? Because there is more evaporation taking place during that time. So, obviously, the percentage of water vapor in the warm and the tropic region is going to be more. Whereas, if you go to the colder regions, obviously, that is percentage is going to be less. So, desert and polar regions have lesser water content in the atmosphere. That is why it is approximately 1% by volume of the total. So, more in the warm and the tropic regions and less in the desert and the polar regions. So that means there is variation that is present here, right? In the polar regions as well as in the warm tropic region. Now, water vapor decreases from equator towards the poles, as you have already seen. Warm tropic region is in what? Close to the equatorial region. As you move towards the poles, the water vapor content will decrease. So now this is again question which has been asked in your preliminary examination as statement along with the other statements. So you should be very clear about these questions. Clear? Okay. Now it decreases with altitude. Obviously, if you go higher, basically if you realize when we will be doing the structure, you see the topography in the troposphere, the lowest layer, that is basically talks about the weather activity. So over here you will be seeing the water vapor content. But as you move up, the amount of water vapor that is present will definitely decrease, right? Now, it observes the part of the insolation from the sun and preserves the Earth's radiated heat. Now, incoming solar radiation is absorbed by the water vapor also, and it preserves the Earth radiated heat. So, it acts like a blanket in order to maintain the temperature. Remember this. This is again a very important activity. It is a natural blanket. It prevents the Earth from becoming too hot or becoming too cold. Clear? Please note it down. Okay, now having studied this, let us move to the next part, methane. Now, methane is something that is repeatedly asked in your papers also, like what are the sources of methane, because it is again a very important aspect with respect to the atmosphere. Now, if you see, it is present in the atmosphere through the natural and human activities which observe specific radiations which basically act as regulating the atmosphere temperature. If the methane content increases, it is basically will be contributing to global warming also to a great extent. And that is why it is very problematic also. UPSC can ask you as a direct question which I have stated right now, but on the other hand, it can ask you the sources of methane. Now, there are natural sources also, and there are human sources also. Like geological sources like volcanic eruptions, from methane also, from ruminant animals also, termites also, they are also associated with production of methane. These are natural phenomena. This is something that you cannot control. But from the perspective of human or anthropogenic causes, you realize that there are agricultural activities, energy production, biomass burning, wastewater treatment, landfills, natural gas distribution. Now, these things are also contributing to methane. Now, overall, these activities tend to impact the percentage of methane in the atmosphere, which again creates a lot of problem with respect to the global warming also. Clear? So, this is methane. Next is ozone. Now, please understand, ozone basically is O3. It is a 3-atom isotope of oxygen. Now, faintly it is blue in color. It is little irritating gas with pungent odor, little bit pungent odor. It is faintly blue in color. Now, it filters the incoming shortwave solar radiation. You know that very well, that ozone is a protecting layer for us. Because if you realize the UV radiation that are coming, right? UV radiation that are coming, possibly if come directly, might cause a lot of cancer on the skin or related issues also. This ozone layer acts as a protective layer. So that is why if you realize, it filters the incoming solar radiation and the harmful UV rays. So it is generally present between 10 to 50 kilometers above the Earth's surface. So very, very important again. Its formation of the process again takes place on a continuous basis. It is not that ozone is present, it is present. It is again chemical reaction that are taking place which leads to its formation. So this layer is generally present between 10 to 50 kilometers above the surface of the Earth. We'll be dealing with that when we'll be seeing the structure of the atmosphere. Okay. Now, there are particulate matter. Now, something particulate matter again becomes very important. This question has been asked repeatedly. A lot of dust particles, soot particles and all are also present in the atmosphere. Now see, atmosphere has sufficient capacity to keep small solid particles which may originate from the different sources. Now, if they are even lighter than the air, possibly they can be pulled up or they can be displaced upward also. There's something very common phenomena. That is why these particles are present. Possibly you will realize that in the Delhi NCR region, you realize that the particulate matters that are present in the atmosphere are so harmful for you. That is why please remember, their increase in the number or composition within the atmosphere is a very, very harmful phenomena also. So over here, it can be through the sea salts, fine soil particles, smoke, soot, again a very important aspect in today's phenomena, ash, pollen grains, dust, disintegrated particles of the meteors. Now these all things are present in the atmosphere. Now the dust particles are generally concentrated in the lower layers of the atmosphere. High concentration of dust particles are generally seen in the subtropical and the temperate region. Now these things should be remembered also. Why? Because these are directly mentioned in the NCERT and they become very important from the MCQ purposes or point of view. Now please remember these particulate matters again is a very important topic in today's time because UPSC can repeatedly ask questions because it is directly mentioned in the NCERT. And it is important from the perspective because it has been in the news also. So you should be very well aware when you are making your notes from these. Please note it down properly and revise it. Clear? Okay. Now comes the structure of the atmosphere. Now please understand, when I talk about structure basically talks about the arrangement of the atmosphere. So we realize that based on various parameters like density and temperature, there are various layers into which the atmosphere is basically divided. Now, initially, please understand, let us see how you make the graph. See, this is basically representing 0 degrees, this is 20 degrees, this is minus 20, minus 40, minus 60, minus 80, minus 100. That means as you move towards this side, it is basically a representation of fall in temperature, right? This basically refers to the height. This is 0 means the Earth's surface. As you move up, this is 10 kilometers, 50 kilometers, 80 kilometers, 400 kilometers, and so on and so forth. These are layers. I will be marking it now. Please understand, this green is basically representing or showing what are the changes in the temperature as you move upwards or there is increase in height. So if you realize if you move from this point to this, that means there is fall in temperature, there is some constant, then increase in temperature, some constant, then decrease in temperature, some constant, then increase in temperature. Now, these are basic guidelines that you should understand. Now coming to the actual concept is, see, this lowermost layer over here you can see is a troposphere. It ends over here, this line, red line basically refers to tropopause. That means pause is there with respect to the changes in temperature. After that comes is stratosphere. This layer is present here, then stratopause. Then you have above that a layer known as mesosphere. Then you have the mesopause. Then there is thermosphere and even you have the thermopause also, though many books do not mention it. But yes, you can write it here also. It can be mentioned also. Thermopause. Some books do not mention. Even the NCERT does not mention it categorically, but standardly in various books it is present. Above that is an exosphere layer, which is very less known because again, it basically merges with the emptiness of the space. So we very less know about it, but we know, okay, this is the layer, last layer, which can be called as the exosphere. Among these, you realize there is a layer of ionosphere, which is basically dealing with the ionization of gas, which we will be understanding, which is very important for the radio communication, which I'll be telling you while we studying the structure. Now, this is a basic hand-drawn diagram, which is very important because if you know this, this question has been asked in the mains examinations also. This has been asked in the preliminary examinations repeatedly, where the temperature decreases, increases, what are the reasons, what are the layers, what are the temperature, what is the, let us say, the height, and how the changes take place, the favorite questions of the examiners, particularly for the PCS as well as the UPSC examination. And remember this concept that this diagram should be learnt by you by heart. You should make it many times, multiple times, only then you'll be remembering it. Clear? Just draw this diagram as a master diagram. So this is what tropopause, stratopause, mesopause, thermopause, troposphere, stratosphere, mesosphere, thermosphere, exosphere. This is the 0, 10, 50, 80, 400, and this is the decrease in temperature. So this graph is basically, this line is representing, as you move upward, there is decrease in temperature, increase, decrease, increase. Clear? Now let's move ahead. One by one, let us study. Now what we are studying here is, see here, we are studying this particular part. Right? Troposphere. This is a troposphere and the upper part is a tropopause. Now see here. It is the lowermost layer of the atmosphere. As you have already seen here, this is the lowermost layer. This is the surface. This is the lowermost layer of the atmosphere because there are so many layers here. So this is the lowermost layer. Now average height is 13 kilometers. Now, if you see the height, maximum height which it reaches is 13 kilometers on an average. Now this varies basically. It is near the pole, it is 8 kilometers, and near the equator, it is 18 kilometers. The reason is, please understand, close to the equatorial region, there are a lot of convectional currents and a lot of cloud formations take place. So that is why it basically pushes the tropopause layer a little upward. That is why you realize that close to the poles, it is not so tall, not the height is not so much because it is simply 8 kilometers. Whereas if you see close to the equator, it is 18 kilometers. On an average, if you see, it is 13 kilometers as average taken place, as mentioned in the NCERT also. Now, all the weather or climatic phenomena that you talk about basically take place in this layer. Now, many will be saying, sir, does that mean that what the clouds we study, majority of them are present here? I would say yes. But if the question comes that there are no clouds present in the above layer, that will be wrong. There are stratospheric clouds also, right? There are stratospheric clouds also. But when we talk about weather phenomena, it is basically talking about this layer where it is confined. So all weather climatic changes take place in this layer. Clouds, majority of the clouds are present here. Some clouds might be present in the stratosphere. This, which we'll be studying in the chapter of clouds later on. Temperature in this layer decreases as you move up. As your height or altitude increases, the temperature will decrease. We will be studying the phenomena like normal lapse rate and all later on. But simple phenomena right now you can understand is, in the troposphere layer, as you move ahead, there is a fall of 6.5 degrees Celsius per 1000 meters. It is also known as normal lapse rate. We'll be studying later on. But as you move up, in altitude increases in this particular layer, this is a fall in the temperature. Clear? So, now this is the major characteristics that you should know. There is a layer, those are tropopause. Now, the zone separating the troposphere from the stratosphere is the tropopause. Why? Because this is a small layer, about 1.5 kilometers, which basically there is no specific change in the temperature. So that means what phenomena of decrease in temperature was taking place stops here. Pause is here, that is why tropopause. And it is separating the troposphere from stratosphere, that is a tropopause word is mentioned here, right? Tropopause. This is the tropopause, right? Now, air temperature at the tropopause is about 80 degrees Celsius over the equator and 45 degrees Celsius. That means, as we have already known that, see here, let us understand. Supposingly, this is the surface of the Earth, right? Let us take this for the timing, that this is, let us say, 0 degree, that is equator. This is supposingly, this is basically poles. Let us say North Pole for the timing. Same thing happens with the South Pole also. Now, if I'm talking about idealistically, ideally, I had mentioned that this is the, let us say, ideally, this is what? Ideally, this is what the tropopause, right? Tropopause means that the troposphere layer ends. There is this zone of 1.5 kilometers and then the stratosphere begins. So there is no change in the temperature as you move ahead in this layer. That is a tropopause. Similarly, other pauses will also come later on in the other layers. So ideally, this is tropopause. If you see over here, right now I told you that when I talk about tropopause, average height is, let us say, 13 kilometers. Let us say just above the troposphere and then tropopause begins. So over here, ideally you can put it as 13 kilometers above the surface of the earth. Clear? But in reality, if you realize, this is not the truth. Why? See here. The reality is, see, this is the actual tropopause, because where the troposphere layer ends. Now the thing that will arise is, you have right now read over here that it is 8 kilometers near the poles and 18 kilometers near the equator. Now see, 8 kilometers near the poles and 18 kilometers near the equator. Now the question will arise, why? Right? I will tell you why, because why I have to explain this diagram is because only then you will understand this phenomena. See here. First thing is, average is 13 kilometers, but in reality, if you see, because 13 is the average, near the poles it is 8 kilometers and near the equator it is 18 kilometers. If you see close to the equatorial region, there is a lot of convective activities take place. Convection, that means a lot of, let us say, because of low pressure region, a lot of air is basically pushed upward. That is why you realize a lot of thunderstorm activities taking place, a lot of cumulonimbus clouds, huge clouds are formed. We will be studying these clouds. That is why I'm not using those specific words also. So you realize over here, a lot of convective activities takes place here. A lot of convective activities take place. Now this basically leads to the tropopause being little upward. Along with it, because the temperature is relatively higher, so there is expansion also. Over here, no such activities take place, so it is relatively lower. This is a region. Now, if you realize one thing, we know something that as you move upward, there is decrease in temperature. Now, though it is above the equator, but the height of the tropopause is 18 kilometers here. It is 18 kilometers here. Over here, it is 8 kilometers. So if supposingly I am at the level of the tropopause, though I am at the equator, I am at a greater height. The normal lapse rate, which I said, decrease in 6.5 degrees Celsius per 1000 meter will also be applicable here and here. So if I say 18 kilometers, you will realize it is minus 80 degrees Celsius here and minus 45 degrees Celsius here. Clear? Minus 45 degrees Celsius here. So please remember, you might get confused that they will ask you that above the poles at the troposphere, there is minus 80 degrees Celsius and at the equator it is minus 45. You will say, yes, it is cold region. Yes, there will be minus 45. No. This is a reality. So you should understand this phenomena, what it means. I've explained you both the things, why this is taller over here, the height is more, and why the temperature is less, because the height is more, that is why the temperature is going to be lesser because of the normal lapse rate, where there is decrease in temperature. The rate is 6.5 degrees Celsius per 1000 meters. Clear? This is the phenomena that you should understand. I hope it is clear to everybody. Okay. Now, another thing here, temperature is constant here in the tropopause, because this is a transitionally layer, because there is no change in temperature within this layer, which is hardly 1.5 kilometers thickness, and that is why this is known as tropopause. This is troposphere and tropopause, which you should be aware of. Now, let's move ahead. We have studied troposphere, we have studied tropopause. Above that is the stratosphere, and again the end of it basically marks the stratopause, right? Now let us see the details. It is found above the tropopause and extends up to a height of 50 kilometers. So close to the 50 kilometers, because please understand, the end of stratosphere or any layer, like troposphere ends here, the tropopause begins. So that means the end of troposphere, whatever the height is given, is basically the start of the tropopause. Similarly, when I talk about stratosphere, it ends at 50. So that means this is the region where stratopause will be found. Yes. So that is why you realize it is found above the troposphere and extends up to a height of 50 kilometers. Clear? Now, this layer contains the ozone layer. Now, ozone layer is not simply that is a very specific defined layer. Now, because ozone formation is a dynamic process that takes place where chemical reactions take place. So, it is between the 15 to 30 kilometer height above the surface of the earth, which you generally find the ozone layer. Now, the ozone layer is a protective layer which basically prevents the harmful UV radiations from coming and causing problems to us. So that is why this is how nature basically has been working to protect us also. Now, this layer absorbs the UV rays. Now, please understand, as I had mentioned, a question may be asked, though we'll be doing the clouds when we'll be doing in the coming chapters, that as I said, weather and climatic phenomena are present confined to the troposphere layer. Yes, it is correct, but it does not mean that the clouds are not present in other layers. The majority of the clouds are present in your the layers of your troposphere, but there are certain clouds like cirrus clouds are present in the stratosphere also. So there are certain feeble winds also moving here. Increase in temperature with height. Now please understand, now the thing is that as you move upward, there is increase in temperature. If you see here, the reason is because the ozone layer being present, chemical reaction being taking place, UV radiation being observed here, leads to increase in the temperature in this particular layer. The major reason for that. So that is why you realize there is increase in temperature over here. Clear? So stratopause basically separates the stratosphere from the mesosphere. So that means this is a stratopause. Again, there is no change in temperature in this particular thin layer. And after that, the mesosphere comes. So stratopause basically separates the stratosphere from the mesosphere, right? Okay. Next comes mesosphere. Now this is a mesosphere. Again, mesopause will separate thermosphere from mesosphere, similar thing. So see here, it lies above the stratosphere and extends up to a height of 80 kilometers, which I have mentioned here. So that means, please remember, if you have done this diagram well, you will be able to answer any type of query that comes or question comes in your examination, because whatever is written over here is basically an explanation of what is drawn here. Clear? So mesosphere, and then you have the mesopause and the thermosphere, right? So up to the 80 kilometer mark, if you see here, it is the 80 kilometer mark, it is still here. Now the temperature decreases with height, again a natural phenomena where as you're going ahead, the temperature is decreasing here. At the height of 80 kilometers, the temperature can fall to minus 100 degrees Celsius also. In the examination, you can be asked which of the layer is generally considered the coldest layer, right? Which is considered the coldest layer. Sometimes it is, sometimes over here you will be coming across this. So within the atmosphere, you will be mentioning mesosphere, generally considered, right? Many meteoroids disintegrate and the shooting stars are generally seen over here, and mesopause basically separates it from the thermosphere. Now this is some details that you should be well aware of, and something that you should note it down also. Quickly note it down. Next comes thermosphere. After the mesopause, you have the thermosphere. Please remember, as I've mentioned you, many books do not mention the concept of thermopause, but again, certain books have mentioned that the end of thermosphere is marked by the thermopause. So you can mention, because the concept is because the temperature keeps on increasing over here. That is why when you move from thermosphere to exosphere, measuring those things become relatively very difficult. So on a general basis, we say that, okay, there is increase in temperature, so we don't have to mention thermopause, but certain books mention thermopause over here. So if you want, you can mention, as I mentioned in the initial diagram. It extends on an average up to 400 kilometers from the Earth's surface. Temperature increases with height. The temperature increases because you will realize that the concept of ionosphere is present here majorly. Obviously, certain parts of mesosphere also, but here also it is present. And that is why that ionization, what this ionization of gas means, which we will be studying. Let us say there is a gas, and due to the UV radiations that take place within a molecule, electron is removed. So it is charged. So these charged particles are present here because of the chemical reactions and the processes that are taking place. That basically again leads to increase in temperature. Further, you will realize that this is a very important layer because the International Space Station is also located here. This has been asked in one of the PCS examinations and long ago in the civil services examination also. So it can be asked as one of the statements also. So International Space Station is located on the lower part of this layer. Energetic solar UV cause ionization, as I mentioned, of the gases. Now, this is what is the thermosphere. Now, the important thing later on comes the exosphere. Now, this exosphere is basically above 400 kilometers, you can take up to 10,000 kilometers also. We over here, this is one layer where you have the least knowledge, least understanding also. So, extends beyond thermopause, ultra thin layer. At exosphere gradually merges into the emptiness. So this is one layer which you realize that this is basically merging into the emptiness of the space. So whatever is above the thermosphere is considered as exosphere. Clear? So this is what is exosphere. Now the important thing which we always talk about is a layer which we talk about, ionosphere. Many people get confused. Some people mention that thermosphere/ionosphere. That is a wrong statement. Or I would say partially correct statement. There is a concept known as ionosphere. Now, ionosphere is basically, again, not a layer which is specifically mentioned like a specific region. It is basically little dynamic in nature also. Now, it is present in the thermosphere and even certain parts of the upper mesosphere also. Now, it is characterized by ionized gases, or ions are present, which are formed due to the UV radiations. They are various layers that are located. Now, these various layers on this ionosphere are very important for the radio communication also. Again, nature has gifted us everything. Now, the NCERT does not go into detail with respect to this particular topic, the various layers. I have mentioned here so that you can basically understand them and note it down, because this can be asked in your papers. It has been asked in certain preliminary examinations of the PCS. So it can be asked in UPSC also very well. These are the layers. D layer between 60 to 99. Now you will be saying, sir, 60 to 99, this will come in the mesosphere. Yes. As I said, these are the layers where a dynamic phenomena of ionization takes place. So these layers which you realize are, ionosphere itself is a part of the thermosphere as well as the mesosphere regions. And it is as the ionization takes place, so this region where ionization is taking place is known as ionosphere. So these layers which are formed are basically divided into various, or given various names, like the D layer, E layer, F1 and F2 layer, right? D layer, basically between 60 to 99, it can be formed depending upon the ionization. Now, it reflects the low frequency waves but absorbs the medium and high frequency waves. So again, used for telecommunication. E or communication, satellite communications and all. Because these radio communication things and all become very important, and this is something what nature has gifted us. E layer between 99 to 130 kilometers, it is known as the Kennelly Heaviside layer. Now, this is one thing that has been asked in prelims also in one of the PCS exams. So this word itself is very important. They can ask you, Kennelly Heaviside layer is associated with which of the phenomena following? Let us say thermosphere, mesosphere, or ionosphere. So that wise you have to be very careful that it is talking about ionosphere. When I talk about 99 to 130 kilometers over here, then you also know that it is present in the thermosphere, but it is associated more with what? Ionosphere. Reflects the medium and high frequency waves. F1 and F2 layer between 150 to 380 kilometers. Now these are called the appellatant layer. Now F1 reflects the medium and high frequency waves, and F2 is generally associated with the sunspot activity cycle that takes place, which we will be studying later on along with that. So these are the few layers, D, E, F1 and F2 layer, which you should be aware of with respect to the ionosphere. Clear? So now comes the concept of structure based on the gaseous composition. Till now you have studied this, right? Troposphere, stratosphere, mesosphere, thermosphere, exosphere. From the base ground surface till the mesosphere, this region is known as the homosphere. Homosphere. Beyond that, it is known as heterosphere. Why? Because in this particular region, the composition of the gases is almost similar. A similar percentage is there. But beyond that, there are certain layers which basically are in a separate composition. At certain region, some percentage of certain gases will be more and some less. But over here, almost a similar composition is present. That is why it is present, known as homosphere. Let us see what it means. Up to 80 to 90 kilometers of the surface of the earth, there is homogeneity in the various gases. Whatever the gases are present, when we were talking about the gases, nitrogen, oxygen and all, you will realize that the composition is almost similar in these layers. But as you move ahead, between 90 to 10,000 kilometers, there is very different set of composition present. Now let's see. As we move from 80 to 90 to above, you will see heterosphere, because over here, if you realize from 90 to 200 kilometers, there is a nitrogen layer, molecular nitrogen layer. Above that, there is an atomic oxygen layer from 200 to 1100 kilometers. Above that is a helium layer up to 3500 kilometers, and above that is an atomic hydrogen layer, which is till the top. So because these layers of different gases are present, is known as heterosphere. Over here, mixed composition of almost similar homogeneity of the gases is present. That is why it is known as homosphere. On the other hand, these are the different layers which are present. That is why it is known as heterosphere. Clear? Okay. This was the lecture from the first chapter of the climate, which we are studying from the NCERT series. Hopefully you enjoyed it, hopefully you liked it, hopefully you're going to study even in more detail so that you analyze and do well in your examinations. Whatever queries you have, you can basically mention in the comment section also. If you like the lecture, you can basically tell us also that you enjoyed it, you learned a lot of things and how it benefited you also. So God bless you, take care. We'll be coming with the other lectures to help you from the various aspects so that you understand and do well in your prelims as well as the mains examinations and finally achieve the goal of being a civil servant. Take care and Jai Hind.